good count?
Yep.
All right.
KGS seismologists and UK Geology students traveled to Frankfort in early April to gather data on the properties of soils and sediments in the area surrounding the recently imploded Capitol Plaza Tower.
Go this way.
They wanted to determine how the soils found here might amplify or reduce the effects of earthquake waves traveling through them. Ed Woolery, who is also a geophysics professor at the UK Department of Earth and Environmental Sciences, along with Seth Carpenter and Zhenming Wang, instructed the students on setting up strings of geophones to pick up energy waves they would generate artificially. For this work, just one geophone wouldn't do.
If we only have one geophone, then we're trying to decide what is the signal, what is the noise. But when we have many geophones out, then we can see the actual signal arrival. It gives us confidence that we're actually measuring the signal that we want and not random noise.
To generate compressional waves, or P waves, and shear, or S waves, that the geophones would pick up, the students struck aluminum plates with a heavy sledgehammer. Seth Carpenter says his earlier monitoring of the implosion of the 28-story Capitol Plaza Tower in March indicated that there is likely some resonance in the soils of downtown Frankfort.
Seismic waves can be bounced up and down, or in this case perhaps back and forth within the soil layers. In the case where certain frequencies superimpose or in other words add up at the right times, then you can have a resonance effect. And what that does to seismic waves actually is it makes what we experience at the surface a much larger in magnitude than what would happen, say, at a rock site, which would not experience resonance.
Carpenter is working on his doctoral degree focusing on resonance properties of soils in the New Madrid and Wabash Valley seismic zones, and hoping to develop a less labor-intensive technique to determine soil resonance. Frankfort is a convenient place for his research.
Although Frankfort it's unlikely that they're going to experience a nearby large earthquake. Still, it's close to home and it's an important location, obviously, being the state capital. And in the event of another Wabash Valley earthquake like we had in 2008, perhaps there was a larger one, it would experience resonance and amplification of waves.
The work in Frankfort generated a complicated set of reflections and refractions of different kinds of waves. They traveled along the ground surface and deeper underground, and arrived at different times back at the geophones. It also provided a good field lesson for the students.
So we've spent all semester thinking and about the theory and learning the theory, and so we're here at the end of the semester, and so I always like to have a field project or a project where we actually go out and apply what we've learned in the classroom.